Yesterday I was talking about how to create a software. Today how to use it. I hope the three persons are interested now in the topic. It's quite astonishing because all talking today about automation, and we do automation since 10 years with the software, so for me it's not really a new topic at the end. I'm talking about DPCM. My name is Ilja Franke, and DPCM stands for Dynamic Power Cloud Manager. And in our department, we are developing software products. It's not only software development, but software product development focused on data center automation. And as I called, DPCM is our main product. The acronym stands for Dynamic Power Cloud Manager. The name cloud came 10 years ago. All were talking about the cloud, but in Germany it's only the private cloud which is the focus at the end. What is IBM Power? He knows IBM Power. Do you know the IBM Power Platform? Power Platform itself, it's a high-performance server family. It's used in data centers, which have a high demand on availability and scaling in a virtual computing environment. It's used mainly or most in SAP HANA processing with the Power 9 generation, the actual generation of power systems. There's also AI processing with graphic cards inside and the special layout of this hardware. The customer have high availability needs. They need disaster recovery if the system fails, that the system is or the business is still running, and even coast to coast recovery from San Francisco to New York if really a great disaster is in the data center. The IBM Power Platform, some elements and tasks. We have a so-called HMC. This is a hardware management control appliance where you can control all the virtual machines on the systems and the settings and the networks and so on. What do you do with these things? Creating virtual machines. It's called in the IBM language, it's an LPAR. I will talk always about virtual machines because for most of the people which doesn't know the IBM Power Platform don't know something to do with what is an LPAR. We install virtual machines with a so-called NIM server. It's a network installation manager. It's also a virtual machine where all the images are from which you install the machines. The operating systems are AIX. It's a Linux or Unix derivative by IBM, but also Linux like SUSE, Red Hat, and so on. For IBM Power I, which is also integrated in the Power family, OS 400 is a special operating system of IBM. We back up those virtual machines, recover those virtual machines. We are moving virtual machines from one system to another system. There's a special IBM moving of system because you can move them while running. So you have an SAP system running, there are people working with this, and you move it live from machine to machine. Next task is daily business, expanding storage or memory, or giving more CPU time for a specific virtual machine. one picture showing how complex it can be defining such systems. You have, you see here the actual virtual machines, and they need some adapters to go to the storage, and they need virtual channels to the actual physical hardware at the end. And this is the virtualization layer here, and you have here those definitions. And if you think about moving a machine with those definitions to another machine, you know, this can be hard to understand and can be hard to do it the right way. Even defining such layout, you can do it on many different ways how you lay out these connections. And if you imagine you have a system running 100 virtual machines, and every virtual machine was done by another admin defining those definitions, it can be very complicated at the end to maintain this. So DPCM is, from our perspective, an automation for this IBM Power platform, brings in standardization in this defining the layout of the connections. It has an easy UI, is fast for the operator, and thus at the end cheaper for the owner of the data system. Talking about the core elements we have in DPCM, we have a capacity and usage monitoring. We have an automatic image deployment, which means installing, updating. We have take care of compliance issues. You know, in the HMC, it's very complicated to define groups and define persons which can do which and what. Then we have a syslog and issues like that. For compliance, also the automatic updating of system with new technology levels is important. I talked about this integrated disaster recovery. We have a mobile app to round it up, and it's multi-OS, so IX, Linux, and OS 400 supported. To get a little bit understanding what we do, one function, we call it recreate, handles the following situation. You have two systems. There are so-called VIOs, virtual I/O processors. In fact, these are also virtual machines, which make this connection I show you in this layout image, the connection to the storage on both sides. We have the HMC and we have DPCM with a separate repository of all those connection definitions and VM definitions and so on. So what you can do if the system fails is that you create a profile for this machine on this side, and if the system fails, you start the machine on this side. It's the same storage here in the center, so you can do it, but you have to maintain this profile here. Maintaining the profile is difficult. Imagine it's not 3 VMs, it's hundreds. So if you make a change here, you have to make a change there. And if you have 100 profiles here, maybe 3 for each machine, you have to maintain them on this side too. So this is a little bit complicated, so we have this recreate function. If the system fails, it's off. We can recreate it from the repository on the system. This is recreate function. Another important function of DPCM in terms of automation is the global LPM. LPM means, I talked about moving a running machine. This machine is running, there are people working on this machine, and you want to move this machine while running to the other system. It's done with the communication between those VIO servers, and to make it complicated, there's a certain amount of machines you can move in parallel. So if you have many machines and you want to move them all to another system because you want to do a firmware update on this machine, so it will be switched off and so on. You want to move those machines all to the other system, automated. And this process is then controlled by DPCM. And after that, you can do your firmware update and move back on the machines. Yeah, we have other automation tasks. Backup, I talked about, even backup for Linux. In IBM terms, we talk about MKSSB, it's make system backup, and we created for Linux instances a sort of system backup, so that the IBM Power admin, which is not so familiar with Linux instances, can simply, with one click, back up the machine to the main server and restore it from there. Also, there is a global system backup which can be scheduled. So each Saturday will be created a complete backup of the system. And we have this image repository for creating new machines, and we expanded that you can use existing machines to create a template, to create from this template new machines. We have pre- and post-processing scripts to fulfill some customer-specific needs. We have HANA support. It's really easy to create HANA instances with DPCM. Think about usually HANA instance needs about 10 or 20 disks connected to the operating system, and it can be hard work to connect 10 or 20 disks to an instance. I talked about the update in IBM language. It's in TL update, which means technology level update. You have to do it from time to time to get some security issues fixed or things like that. It's very easy to do this updates with DPCM. Yeah, at the end, what is interesting for those people which buy DPCM, what do I have financial benefits when I use the software? The first is to save money. One point is there are existing high availability cluster software which you can buy and which have tremendous license costs. If you are content with maybe 10 minutes downtime of a system when there is a failure, then we can achieve this with our recreate function. So we don't need this cluster software, and the customer don't need to buy the licenses for this. The next is that we have through the automation and radically faster handling, and so the operating costs are lowered. We save time and we improve availability, which can save money too. From an operational point of view, we have this compliance issue I talked about. We have the standardization. be lower skill needs. It's difficult to control the power system, and if you are not really familiar with it, it may be a problem for you even to start a machine. So with a nice UI, you can give it to the operation team. Yeah, if the virtual machine must be started, press on a button and all is fine. Yeah, the next one is we have customers created themselves scripts to control the data center. Each time IBM brings new versions, there will be changes, and these changes may affect the scripts. And DPCM, you get the update, and the new version is supported, and the customer doesn't take care about this. If we have a look to the operational efforts, some samples to create a virtual machine with IAX installation and customization. Normally, if you create it with the HMC, maybe you have 60 minutes to work, step by step. With DPCM, you simply fill in the dialog and hit on OK, then 10 minutes waiting, and your machine is created. Creating a disaster profile and with cloned adapters to the storage. Also 60 minutes work step by step. In DPCM, it's just the recreate button, 5 minutes waiting, finished. System migrations. You have two systems, 85 VMs in a vSCSI and NPIF environment. Maybe you need 12 days to move all these systems and VMs to new ones. With DPCM, you can do this in 1 day. Storage migrations as a sample for 4 systems, 70 virtual machines. Here as a sample, 25 days is done in 10 days. So this is the reason why people are using DPCM. Again, a sample as from a point of view of operational costs. We have 8 systems, 55 virtual machines. Firmware update. Without DPCM, we need a day, I think, here. And system recovery, backup check, capacity reports, all calculated for a year, how much time we need and how much cost we save at the end using DPCM. Yeah, we have a history. I talked about it at the start. 2011 we started with DPCM. We didn't start from scratch. There were 10 years of development of scripts where people are working and automate for while being in field things. And 2011 we had the idea to have an application to control those scripts at the end. And so started it, and it escalated quickly. So from then till now, we have functional needs, functional enhancements, which came through field work or customer needs. And we have automatically growing data center size. So we started the first DPCM we installed, I think it was 2 systems and maybe 10 virtual machines in a static environment. But we ended up with customers which had maybe 50 machines and thousands of virtual machines at the end. During these enhancements, we decided that you have to completely rewrite the system. This is the new version. We call it Snowblues because it's really new, and we need a fancy name, and our fancy name is DPCM Snowblues, and this development is still ongoing at the moment. The technical base for the first version was open source, 100%, based on Ajax with Dojo, Apache Tomcat MySQL at the backend, and KSA scripts which do the communication to the data center at the end. In the new version, Snowbrews, it's all based on JavaScript completely, from the client to the backend. We have a stack with Bootstrap, GraphQL, React, Nginx instead of Apache, node.js as backend, and around this also open source software, Postgres for persistence issues, Influx to store performance data, and Docker for integrating all these parts the system is built up. What is new in the new version? We have a new user interface. We have a scalable backend architecture. We have written an own performance collector in the first version. There's also an open source software called LPAR2RD. We have issues with that, so we wrote them for ourselves, and we have a complete functional support for all issues we have in the Power environment at the end. And added now Ansible support for automation issues and customization on customer side. A little bit about look and feel, that you have an idea how the software looks like if you're using it as a user. We have two clients. There's an administration client and a client the normal operator will use. In the administration client, you do the base settings of the system, and like directory configuration for authentication, and we have an own user management. You can connect to a directory, so this is done automatically, but we have here inside local credentials we need for assigning to groups or assigning to roles. So it is possible to create a mix of local users and users which coming from or which are assigned to a directory. In the roles, we can define exactly which function each user can use. You can create your own role and say this role have the ability to tag a system, to list systems when the person is assigned, and this and that. All functions which are in the UI you can assign to a role. We have an API for the software, and this API description, which functions, which arguments you can use, it's automatically documented in the admin client. You can define services that is a permanent token, and you can access DPCM from outside. Where do you need this? Maybe for Ansible scripts. If you have an Ansible script, you want to have this inventory in Ansible, the actual inventory, and this Ansible plugin needs a service API token to get access at the end to DPCM. Yeah, one more sample. There are much more things, but just for illustration. Network definitions, where you can put into DPCM and it's used later by creating a machine. It knows where's the install LAN and so on. Coming to the client, we have a little bit welcome screen, some basics and some videos how to use the software. And looking to the systems, we see several systems which are combined in a data center, which you can define. So you can define in which data center you want to see which systems, how the CPU usage of the whole system is actually the memory usage. And you can see on a tab latest 24 hours CPU usage in this sample. Yeah, it's a list of virtual machines of this data center where you can filter and do much things. You see this performance mini graph here is sorted by performance. You see the machine with the most activity is now the first one. And simply by sorting here on performance, you switch to this machine. If you open or click on a machine which I have filtered here, then you see here details of this machine, how its CPU is defined, how the memory is defined. You can see the vSCSI adapters and so on. At the end you can also, which is sometimes interesting for reporting issues, if you hit on this button you get this in Excel. And this is on every table you can do this. Terminal access, so I hit on this terminal and then I get terminal access to this machine. This is working with the DPCM as proxy. So if you are connected to DPCM, you don't need a direct access to this specific machine. So it can be that this machine isn't in the network where you have access via HTTP to the server. So this is really a good feature at the end for remote support. Yeah, we have analysis section where we can scroll to the performance. You see the defined capacity is here in the gray. So this machine is always running over the defined capacity. So you have to increase this here at this point. When we have time, I can show this live. Network. Also for the porting, what you do in power system environment is a sort of over provisioning. You have 10 machines and you have 16 cores maybe in this machine, and maybe you say, okay, I want for this machine that it use 2 cores and use, it's called entitled capacity, how much percent this machine should be used. And if this machine is using sometimes more and other machines doesn't need so much CPU or capacity, then it move it. But it cannot be a permanent issue. So this report helps to identify machines which are over or beneath the defined capacity running, maybe the last week or last month or so. Yeah, the functions starter for n. I see this machine is not running. It's an AX machine, and I want to start it in normal boot mode with a certain profile, the default, and I can select a script which should be executed after the machine is started. Maybe check if the application is starting to, and so on. Yeah, then we have this progress bar where we are at the end. This is the very new docket. We call it docket. In fact, it's Ansible playbooks you can use to be used in the start script or to fulfill needs like disaster plan. You have a plan. If anything is happening, I have to move this machine to that system. I have to switch off some testing machines on the target system, and I have to recreate this and that machine, virtual machine on this system, and you can script it in a playbook and simply start it. An extract which customer use DPCM, Lufthansa systems and others. We have a business model around the software. This is the software itself, where we buy all the licenses. We have the services for the system engineers controlling the power processing of the customer, and we sell the power hardware itself, and on top support for the software and for the power service too. We have a license model, which is the licenses are by course of the systems. There are system types in the IBM world, small, nowadays only mid-size and enterprise systems, and the pricing is by type. For enterprise systems is a little bit expensive as for mid-size systems. You can rent the software, or you can even operate your complete power environment by us with DPCM at the end. And we have an enterprise agreement program for big customers. Maintenance, it depends if you are buying the maintenance for a year or for 3 years or more. So it's 22 or 80% of the license value which, for the maintenance, and it's included in the other models like renting or operations. This was a talk yesterday. I talked about how we created the software. Before we started to create the new version of DPCM, we created a framework or a template where we can create software with, or create applications with. We have a sample with Omixon we did. It was a project prototype with a workflow over 3 different types of people, and document is going through the workflow. We created it in 4 days, so it's really efficient to work with this framework. We created the Axians portfolio radar. It's I don't have an image here. It's a very graphical drill down through the technologies we use in Axians. DPCM operations is important to control all these licenses and which version, which customer has, and which version of system, VO and HMC he has actually installed. CPAC, I will talk maybe next year about it. So it's then the mass operations and NTO portal, and also internal applications which we use in Axians IT solutions, which are created with this framework. A little bit about my team. This is me, myself and I. Michael, you will see him here running around. The second Michael too. Anthony is a student in my department, and the 2 main power guys which help to explain how IBM Power works, which is always complicated, even for me programming 9 years for this product. So there are not so many people, so if you have any questions, we have any time, I think. And I can show the software also live if you want.
What's the main advantage to PowerVC from your side?
PowerVC is in many points restricted to a very specific way how PowerVC works. Yeah? And DPCM you can configure to any sort the customer does this application. It's one point. There are many points we can talk about. We can talk about storage management. We can talk about the updates, how restore is done, and so on. There are many points you have to discuss with the power guys. Sometimes, because I'm not used to use PowerVC, so personally I cannot tell you so much the differences. But I knew that there are reasons. Fine.